So once we know the quadratic formula, we can apply it, and we can find the roots of equations. I should say quadratic equations that aren't easily factorable, or we can't use complete, or we don't want to use the method of completing the square. Although this quadratic equation is a good candidate for completing the square because this number in front of the x squared is 1 and this is even. So these are the two factors that make this a great candidate for completing the square, but we're going to use the quadratic formula just to get some practice. So we know that if our formula is in this form, ax squared plus bx plus c equals 0, then these are going to be the numbers a, b, and c that go into the formula. So first of all, let's identify what's a, what's b, and what's c. So a is whatever's in front of the x squared term, so that's just going to be 1 because it's 1 times x squared. B is whatever's in front of the x term, so that's going to be equal to -6. And c is the constant, or the number, numerical term, which is just 4. So now what I do is I rewrite my formula, and I just write it and I just leave the a, b, and c out and put parentheses there so I don't make mistakes. So x equals minus b plus or minus the square root of b squared minus 4ac. So I write it like that. It's kind of long. I'm going to use a ruler here, like straight lines. I'm one of those people, if I don't use a ruler, I can't make my lines straight. And that's going to be all over 2 times a. So you see we have basically the shell of the formula. And then we just have to put our a, b, and c in. So b, every time I see a b here, I'm going to put a -6. So I got a -6 there. Now remember, we got a negative in a formula. A negative in the formula and a negative in the data. I have a -6 here. And every time I see an a, I put a 1. So there's an a there. And there's an a there. And every time I see a c, I put a 4. So now we just have to evaluate that and simplify it. X equals, and a negative times a negative is a positive, so positive 6 plus or minus the square root, and -6 squared is positive 36, minus, and 4 times 4 is 16. And that's all going to be over 2 times 1 is 2. And that's, we can write this over here, that equals 6 plus or minus the square root. And what's 36 minus 16? I think that's 20. We always want to simplify our square roots, so remember 20. I guess I can do that over here. 20 is the same thing as the square root of 4 times 5. Isn't that 20? And the square root of 4 is 2, so that's the same thing as 2 times the square root of 5. So I can rewrite that over here. So the square root of 20 is the same thing as 4 times 5. The square root of 4 times 5, and the square root of 4 is 2. So 2 times the square root of 5 all over 2. Now you got to be really careful here. We have a binomial in the top and a monomial in the bottom. We have to make sure that all 3 numbers are divisible by 2 if we're going to simplify. Sometimes people just do this. You have to watch everything. So the safest way is to factor. You may not like to do this, but it's a safe way. What can I factor out of these 2 terms? It looks like I could take out a 2. And what's left is 3 plus or minus the square root of 5 all over 2. And 2 over 2 is 1, so my answer is just 3 plus or minus the square root of 5. And it works out nicely like that because this is a good candidate for completing the square. So now we have 2 roots. X equals 3 plus the square root of 5, and x equals 3 minus the square root of 5. And then we could calculate that out, and if we found those numbers, that's where it's going to cross the axis. In other words, The square root of 5 is, well, what's the square root of 4? The square root of 4 is 2, so let's just say this is 2.2. So this would be 3, and this is approximately, I'm just approximating. 3 plus 2.2, which is about, what, 5.2. And this would be 3 minus 2.2, which is about 0.8. Now this is just an approximation. I don't have a calculator, so, but I know the square root of 4 is 2, so the square root of 5 is a little bit bigger. So this would be maybe about 0.8. So if I put these on my graph, 0.8, if I look over this is going to be, oh, it didn't draw a very good graph, excuse me, but there's 1, 2, 3, 4, 5, maybe that's 6, and maybe that's 1. And 0.8 is a little bit to the left of 1. It's not quite 1. And 5.2 is a little bit 1, 2, 3, 4, 5. This is 5, so 5.2 would be over here. So it looks something like that. So I know my parabola, and I know since the x squared is positive, it's shaped like a U. I know it's going to go through these 2 points, so I found the 2 zeros. In other words, the value of x that makes this vertical position 0, so it's going to be here and here. So my parabola might look something like this. Now I don't know how far down it goes because I have to find the vertex, which I could by using minus b all over 2a and then putting that back in the function if I want to get a better graph. But I know it looks something like this. I do not know how low it goes, so I'll just say it goes down like this somewhere. So notice we've got 2 real roots. Oops, sorry about that. So you should be able to graph them. Get an eye with the roots, you can put this down and you get a good graph of the parabola. And try to do that, and you use these approximations. You know what the square root of 4 is, you know what the square root of 9 is 3, so it's somewhere between, the square root of 4 is 2, the square root of 9 is 3, somewhere between 2 and 3, so you can approximate. Okay? So I guess that's example 1.